Welcome to the cold working shop. Well, the piece came out pretty good. I'm somewhat optimistic that I might have a success here. I don't know if this guy will show up very well on the camera, but I will certainly make nice photographs of it once it's finished. So now I'm out at the lap wheel. This is a experimental prototype custom-made lap wheel, which is still under development, not currently offered for sale. Who knows, maybe someday, but in its present form, it's good enough for me. Certainly is not good enough to sell to the public, but in the current form, it's good enough for me. So I'm going to move the camera and show a little bit about what's going on. The cold working process is really slow and really boring. So I'm not going to show the whole thing. I'm going to show little highlights here and there that kind of illustrate how the process is done, how the machine works, and what I've added to traditional lap wheels. Obviously, lap wheels are a commercial product that's been around for a long time. There's a number of suppliers make excellent ones, and I've got maybe a little bit of additional invention and a few extra ideas that make mine just a little bit special. Like many other lap wheels, kind of a traditional design, my wheel has a steel platen, and that means that the diamond discs with magnetic backing will stick in place. I also have center water feed, which is not an original invention. I've seen it on commercial units, but it is a very useful thing. I find that it works very well, and I do it maybe a little bit differently from the commercial products. Most important thing that makes this lap wheel unique is the arm assembly, which is kind of maybe in a slight way similar to a faceting head. I could probably put a full faceting head on this and do faceting, but at the moment the idea is to relieve some of the drudgery by having a rotating vacuum cup. The vacuum cup has, well, first of all, it's CNC machined out of Delrin, and it has an O-ring precisely cut, a rubber O-ring precisely cut into the face, and then a hole and a rotary seal so that it's connected to a vacuum pump. I've got a water separator here just in case one of my murrine slices just happens to have a hole in it or something, and a little bit of water gets through, or maybe it doesn't seal correctly on the rubber O-ring. I don't want the water getting into the vacuum pump, so I've got a water separator over here, and then just a regular El Cheapo Harbor Freight vacuum pump. Works great. So to start off with, I'm going to be doing it by hand. I'm going to start by just trying to get this front face a little bit flatter than it is. It's mostly flat. The hot work actually was reasonably successful at flattening it, but it's not quite flat enough to give a good vacuum seal. As soon as I get a sufficiently flat surface to provide a good vacuum seal, then I can move into automated work. I'm using a metal disc, a metal diamond disc, and I believe that this is the 100 grit metal disc, because the first stage of rough grinding, I need to remove a larger amount of material. Of course, when you're talking about glass, even a coarse disc removing a lot of material is still removing a tiny amount of material by woodworking standards. When a woodworker talks about using coarse sandpaper to remove a lot of material, they're talking about a very different situation than a glassworker using a 100 grit diamond disc. I'm still only removing fractions of an inch, but glass is hard, diamond lapping is slow, and even a coarse disc really doesn't remove that much material. I'm talking about removing thousands. And getting closer, you see the pattern starting to emerge, and it looks like it's going to be a pretty cool pattern. Fairly happy about this. And of course, at this point, I have to be oh so careful. A lot of work in one of these things. And let me see if it'll hold vacuum now. Not quite. I'm going to turn the camera off and swap this out for a smaller size. This piece is a little bit smaller than the last one. Even though I try to hit my targets precisely, this one came out just a little smaller than I would have liked, and so I'm going to swap this cup out for a smaller one. Okay, the swap out has been completed. I've now moved to the smaller diameter cup, and unlike the squeezer, this thing does not have a quick disconnect feature. It still requires fairly inconvenient screwing. So another thing on the to-do list. But for today, it's good enough, and I can continue making progress on this piece. It's very, very close now. And the surface is starting to get smoother, even though I try as hard as I can to perfect the surface in the hot shop. Yeah, I think that's fitting really well. Gonna go over to the wet saw and very, very carefully, I mean carefully, try to separate this guy from its punty. Now, who knows, maybe there's a way to separate that in the hot shop, but I wouldn't want to try it. Make a small cut, rotate to the next face of the hexagon with the blade barely kissing the finished surface. Very, very gentle pressure. And there we go. So now the piece has been separated. There's very little of a punty mark. So now I'm going to get serious about grinding this guy down. Vacuum pump on. Just a El Cheapo Harbor Freight vacuum pump, nothing special. Get the piece lined up and verify that it's stuck down but good. Because if this thing came loose at this point, it would be somewhat disastrous. Surface actually looks really nice. Pattern looks good enough. They're never perfect. I keep trying to make them perfect, but they're never perfect. So, here we go. The mechanism has an indexing pin and then an array of bronze bushings so that it can be used almost like a kind of a crude faceting head. But for this application, it's just going to be rotated. Then I've got this lead weight that I fabricated, and gonna set the timer. And then mostly I just let it sit like that. Just watch it, sometimes maybe move it back and forth a little bit by hand. And of course, while I'm doing it, I'm thinking, well, I wonder how much trouble it would be to create a oscillating mechanism to work in addition to the rotation. But at least at the moment, I don't think I need it. So gonna be grinding and grinding and grinding and grinding for a very long time, and I'm certainly not gonna show it all because it's really boring, but hey, at least I don't have to do it by hand. I think everybody that I've talked to or read about who does cold working hates cold working, especially when they get their fingers a little too close to the lap wheel and end up grinding off the end of their skin, which is surprisingly easy to do because wet skin grinds almost painlessly and you don't even notice it, and then later you look at your finger and you go, why is my finger bleeding? I gotta be really careful when using this machine, and like so many things about glasswork, there's a bit of a mystery involved. Sometimes I'll grind and grind and grind for 10 minutes, 15 minutes, 20 minutes, look at the result and nothing happened. Other times I'll grind for 2 or 3 minutes, look at the result and uh-oh, that was too far. So, I don't know. There may be mysteries I don't quite understand. Maybe different colors react differently. Maybe my wheels are getting worn out. Maybe it's voodoo doo-doo and evil spirits. I don't know. So rotate around, kind of feel the surface. Not flat yet, but made very good progress in 2 minutes. So, back again, reset the timer. So, I'm going to be starting with the 100 grit metal wheel, then moving to a 270 grit metal wheel, followed by a 220, what they call the polishing disc, the resin bond polishing disc, and then a 325, a 600, and a 1200. Other marine makers that I've talked to say, why are you using so many different wheels? You can go directly from the 325 to cerium. And I've had better luck. I think I get a little bit better result, and to me it looks better to my eye if I use the multiple, use more steps. It doesn't matter if it takes a little longer. Of course, from woodworking, I remember that the rule in woodworking is that every piece of sandpaper produces a scratch, and so you start with the coarse paper, then move up a grit until you've removed all the scratches from the first step, and then continue at each step making finer and finer and finer scratches until finally the scratches are invisible, or at least small enough that they're not noticeable without a microscope. And so I'm following more of the woodworkers' rules of just going step by step through the grits, one right after another. So that's probably, I don't really need to show the entire process. I think you can pretty much get the idea what's going on here. So I will, once it's done, I will take a nice still photograph and show the results. So see you later. Everything is continuing to go well. I've got the surface smooth. Everything looks fine. Pattern looks good on the 600 grit wheel. And it just continues slowly. 1200 grit wheel, all continues to be well. I'm anticipating great success. And very happy that the machine is doing all the work. Cold working by hand is pretty darn annoying. So I'm finally down to the last step in the process, which is polishing with cerium oxide. Cerium oxide is a powder that's kind of like dissolved, not really dissolved, kind of like form a suspension of some sort in water, and then you just kind of like squirt it on your felt pad, and it looks like the system is oscillating on its own for its own reasons, which is kind of good. I kind of like that. Cerium oxide on a felt pad is used not only by artistic glassworkers, but also telescope makers, anybody who grinds a lens, any kind of precision optics. And get my timer going here. It's a kind of a combination of a very, very fine abrasive powder, and I think it actually has some chemical action as well. Not exactly sure how this stuff works, but it does work. Produces a very, very nice, smooth, shiny finish. Really beautiful. And anyway, that's the last step in the process. After this is done, the piece will be complete. Okay, back in my office, the glasswork is finished. I've got a nice still photograph of the resulting piece, and hey, I think it came out pretty good. It's a little smaller than I wanted. I still haven't developed the skill to hit the target perfectly. I'm getting closer. They get closer every time, but this one is a little smaller than I wanted. I may or may not reuse a similar sculpture base design. I'm starting to think of different ideas, so I'm going to take a few days and think about it, do some designs, do some CAD models, and then once I come up with a base for the sculpture, go out to the machine shop and make some machining videos showing how that part is done. Haven't done a machining video in a long time. So anyway, thank you for watching. If you learned anything, well, that's great. If you were entertained, well, that's great. You know, it's It's all good. It's all good. Sharing knowledge is all good. All of art, music, science, engineering, everything is better when ideas are shared. And I hope that sharing my ideas and sharing my work, maybe has helped somebody, maybe entertained you, maybe, who knows. Anyway, thank you for watching. It's been fun.